Old cars were made to be very solid. In an accident, the car might well have hardly been damaged at all, while the occupants might have been killed. Modern cars are now designed to crumple up on impact. But how does that help minimize injuries to the passengers? The answer lies in Newton's second law of motion. According to Newton's first law of motion, the presence of an unbalanced force will accelerate an object, changing its speed, its direction, or both its speed and its direction. How do we calculate this force? What is the relationship between net force and acceleration? Let's observe some real-life events to find answers. That table tennis ball hit a player, but the player is not badly hurt. However, cricketers wear special gear to protect themselves from injury from fast-moving cricket balls. Why? What is the difference between the two balls? The cricket ball is heavier than the tennis ball. We can conclude that the impact of an object is dependent on the mass of that object. On the other hand, a bullet is much smaller than the cricket ball. But it can kill a person when fired from a gun. How can such a small bullet be so lethal? Because it is traveling with great velocity towards its target. These observations suggest that the impact produced by objects depends on their mass and velocity. These observations were used by Newton to introduce a property called momentum. The momentum P of an object is defined as the product of its mass, m, and its velocity, v. That is, P equals mass multiplied by velocity. Momentum is a vector quantity. It has both magnitude and direction. Its direction is the same as that of the velocity of the object. The SI unit of momentum is kilogram meters per second. We know that the application of an unbalanced force brings about a change in the velocity of the object. Momentum is the product of mass and velocity. Therefore, an unbalanced force also produces a change of momentum. Let's look at another situation involving unbalanced forces and momentum. The battery of your dad's car has died. You and your brother are pushing the car to get it started. The car needs a velocity of 1 meter per second to get it started. You and your brother push. The car barely moves. You keep pushing, and slowly the car starts moving and gaining speed. You keep pushing till it starts. As you can see, the time over which the change of momentum takes place also impacts force on an object. The second law of motion states that the rate of change of momentum of an object is directly proportional to the applied unbalanced force and takes place in the direction of the force.